with the accelerated motion and accelerated motion in one dimension. So the problem, especially we are doing the numericals based on calculus and try to understand the physics with the help of calculus mathematics. Okay, so before we start, the question I am writing, I think this is from your textbook only. The question is, a speed time graph of a particle moving along a fixed direction is shown in the figure. Now I am showing you the figure. Here is the speed time graph. Okay, the speed time graph. And this speed is given to you. That is maximum speed. Maximum speed is given to you 12. 12, and this is in meter per second. Time in second. Time is measured in second. And the time interval, this is 5 seconds, 0, 10 seconds. Okay. The question is, you have to find the distance covered by the particle between t is equal to 2 seconds and 6 seconds. Find the distance. Find the distance covered by the particle in t is equal to 2 seconds to t is equal to 6 seconds. This is the question. The interval is between t is equal to, so particle between t is equal to 2 seconds to t is equal to 6 seconds. This is the question. You know, the area bounded under a speed time graph gives the measure of distance. So how will you find distance covered? So just take the area. But if you find the area of this triangle, this will give you the distance covered in 0 to 10 seconds. But this is not our question. Our question is, you have to find the distance covered by the particle between t is equal to 2 seconds. So let us make it 1, 2, 3, this is 4, 5, 6, 6, then 7, then 8, then 9, then 10. So you have to find this t is equal to 2 seconds to t is equal to 6 seconds. So you have to find the area of this trapezium. Area of this trapezium. This gives you the distance covered in t is equal to 2 seconds to t is equal to 6 seconds. So then you need this part. So what is the speed of the particle at t is equal to 2 seconds? This you have to find. And then the speed of the particle at t is equal to 6 seconds. That also you have to find. So to find the speed of the particle at t is equal to 2 seconds, speed at t is equal to 2 seconds. The particle starts from rest, as the graph shows that initial speed is 0, and you can find the acceleration also. So acceleration within this portion is slope of speed time graph. So magnitude of acceleration A is equal to, slope is how much? 12 by, that is perpendicular by base, and base is 5. So this much meter per second square is the acceleration. Now speed at t is equal to 2 seconds. So if it is v at t is equal to 2 seconds, then u plus 80. Okay, u is 0, a is 12 by 5 into t is 2 seconds. So this is 24 by 5. That is 5 4 ja 8 meter per second is the speed of particle at the end of 2 seconds. So this is known to you, 4.8. Now think about the speed at the end of 6 seconds. So after attaining the maximum speed, 12 meter per second, now the particle starts decelerating. So this will be treated for this region, deceleration. If you find deceleration, so deceleration is also 12 by 5, but with a negative sign. So deceleration A in that region, A is equal to 12 by 5 minus. So this is, okay, keep it minus 12 by 5 meter per second square. So deceleration is from 12 meter per second to final velocity speed 0. So just to find the velocity at the end of 6 seconds, you consider this one as initial velocity. So velocity at the end of 6 seconds is equal to velocity at the end of 5 seconds. This will be treated as initial plus acceleration. So I will take A is equal to minus because this is the retardation part into T. T is 1 second. 5 to 6. So 5 to 6 is 1 second. Then V at the end of 6 seconds, V at the end of 5 seconds is 12 plus A is minus 12 by 5. So take it minus 12 by 5 and then 1. So then velocity speed at the end of 6 seconds is 12, 1 minus 1 by 5. So this is 12 into 5 minus 1, 4 by 5. So it's how much? 48 by 5. So if you divide it, you will get 9.6 meter per second. So this way you are getting this speed also. I mean speed at the end of 9.6 meter per second at the end of 6 seconds. Okay, now you are in a position to find the area of this trapezium. So actually this is area of two trapezium. The one I can name it A, B, C, D, E and then F. Okay, now distance covered. Because it is speed is decreasing, no? Speed is decreasing. So if the speed is decreasing means deceleration. So acceleration follow in negative sign. So distance covered in between t is equal to 2 seconds to t is equal to 6 seconds is equal to area of trapezium. So two trapezium, that is ABEF plus area of trapezium yeah BCDE. Okay, so how will you find the area of trapezium? Half into sum of parallel sides. So these two are parallel sides and this is 4.8 and this one is 9.6. So this is 4.8 plus 9.6 into perpendicular distance. No, this is 4.8 and you have to take this side. So this side is 12. So write here 12 only. 12 into perpendicular distance between these two parallel sides. So 2 to 5, the perpendicular distance is 1, 2, 3 seconds. Plus, again area of second trapezium, this one. So this is half into sum of parallel side. So this is 12 and this is 9.6. So 12 plus 9.6 into time interval, this part is 5 to 6. So 1 second. 1 second. Just solve it. You will have the answer. Okay. So it is how much? 6. Am I right? No, 12, 16. 16.8 into 3 plus 1 by 2 and this one is 21.6 into 1. Now take 1 by 2 common. So this is 1 by 2 and then 16.38 into 3. It's how much? Yeah, tell me. 50.4 plus okay, you are telling after dividing it by 2. Now I am adding first. So this is 21.6. So it's how much? Half into this part is 0 to 72.0. So if you divide it, this is 36 meter. Is the total distance covered? 36 meter. So the distance covered in between t is equal to 2 second to t is equal to 6 second is nothing but 36 meter. This is from your textbook. If you see the textbook, you will find this question is there in the additional part, I think so. Okay, now take the snapshot. This is page 1 and then question number 1 and then I will do the second question. Okay, take the snapshot. Similar triangle. This side, yeah. This side with this side is equal to this side with this side. That's also okay. That's also right. That's also right. Have you taken the snapshot? Yeah, someone has taken or not? Taken. Just reply. Have okay. Then we are solving another problem. Now, especially the problem based on calculus mathematics, importance of calculus in physics. So, you will just see a very interesting problem, that is an object moving with a speed of 6.25 meter per second. An object moving with a speed of 6.25 meter per second is decelerated at a rate given by at a rate given by dv by dt is equal to minus k, some constant is there. Now, minus 2.5 root v, minus 2.5 under root v. So, this is the equation of deceleration. So, the object is decelerated at a rate given by dv by dt minus 2.5 under root v, where v is the instantaneous speed. Now, find the time taken by the object to come to rest. Now, find the time taken by the object to come to rest. Remember, this v is instantaneous velocity or speed. An object moving with a speed of 6.25 meter per second is decelerated at a rate given by dv by dt is equal to minus 2.5 under root v. It means the object is going to be in rest from a speed 6.25 to the final speed 0. So, you have to find the time taken by the object to come to rest. Okay, this dv, should I write minus 2.5 dt and then under root v should be taken here. No problem. So can I write this one is the under root v means v raised to half minus half, because here it is v raised to half, and if you bring it in numerator it will be v raised to minus half dv, and this side it is minus 2.5 into dt. Just integrate it, integrating both sides, okay, with the limit t 0. So at t is equal to 0, what was its speed? The speed, initial speed is 6.25. Now it takes, suppose t times the interval, after interval t, its velocity becomes 0. So the object will be in rest. So 0 to t, this time interval is t, and then its velocity becomes 0. The speed becomes 0. Then the object will be in the position of rest. Now this is the scenario. Just integrate it. And you know how to integrate x raised to n dx. This is x raised to, this implies x raised to n plus 1 by n plus 1. X raised to n plus 1 by n plus 1. So instead of x we are writing v. So v raised to n. N is minus half power. So minus half plus 1, n plus 1 by n plus 1. And then the limit part is 6.2520. And this side it is minus 2.5, and then integration dt is nothing but t. But limit is 0 to t. Do you have any problem to understand this portion? Okay, am I right? Integration, we are using the formula integration x and dx is equal to x raised to n plus 1 by n plus 1. Again I am writing once again the formula integration x and dx is nothing but x raised to n plus 1 by n plus 1. Using the same formula, so instead of x we are taking v, instead of n we are taking minus half. So based on this, this is minus 1 plus 2 by 2. It's how much? 1 by 2. So should I write in the numerator minus plus 2 minus 1 minus 1 1 by 2. So this is 1 by 2, so 2 is taken in the numerator. And then this part is v raised to, again 2 minus 1, 1 by 2. So v raised to 1 by 2 raised to, the limit is 6.250, and then minus 2.5, and just put the limit t minus t0. Yeah, minus, it's only 2. Yeah, right. So this is 2, and then we are putting the limit. If you put v0, this part will be 0. Minus. If you put v is equal to 6.25, then raised to half. Okay, you have already substituted the limit, and this is equal to minus 2.5 t. So this way you are getting minus, this minus sign, minus 2 and 6.5 under root 6.5. It's how much? 2.5, and this is equal to minus 2.5 t. Should I cancel 2.5, 2.5 minus minus also? Now the final answer is, after t is equal to 2 seconds, the velocity speed of the body becomes 0. So the finally the body will come into rest. So after a time interval of 2 seconds. So if the retardation is varying with the velocity by the relation given here, then you have to find the time taken by the object to come to rest. So after 2 seconds, the object will come into rest. Okay. Now moving towards the another question. Taken the snapshot. Taken. Yeah. Okay. So should I move for next part? Next part is Now we are writing the another interesting question. It is no doubt. I will discuss the other portions also. So first we are dealing, a particle moves along a straight line such that its displacement s at any time t is given by s is equal to, the relation is t cube minus 6t square plus 3t, t cube minus 6t square plus 3t plus 4. This is the relation. This is in meter. Okay. Find the velocity when the acceleration is 0. The question is, find the velocity when acceleration is 0. When acceleration is 0. So how will you solve this problem? Find the velocity when acceleration is 0. To solve this type of problem, you have to find instantaneous velocity first. So this v is nothing but ds by dt, dx by dt or ds by dt. So just differentiate it. d by dt of t cube minus 6t square plus 3t plus 4. Yeah, it's clear? Now, if you differentiate it, then what is differentiation of t cube? This is 3t square. Actually 3t, 3 minus 1. So 3 minus 1 is 2. Minus 6. Differentiation of t square is 2t. Plus 3. Differentiation of t is 1 only. Because dt by dt, 1. Plus differentiation of 4, which has no t, now it is a constant and this is 0. So finally you are getting 3t square minus 12t plus 3. This is v. Okay. To find acceleration, you have to differentiate v. So dv by dt is called acceleration. So acceleration a is nothing but dv by dt. Now we are going to differentiate velocity. So 3t square minus 12t plus 3. So you know how to differentiate it. So 3 into 2t square. T square is 2t minus 12. Differentiation of t is 1 only plus differentiation of 3 alone. Since no t is involved, that's why it is supposed to be 0. So this part is 6t minus 12 acceleration. Now your question is, find the velocity when acceleration is 0. Okay. So if you put acceleration 0, you will get the time. So at what time the acceleration will be 0. So if a is 0, then what will be that? T. So if you put a 0, then 0 is equal to 16 minus 12. So t is equal to how much? 12 by 6. So this is 2 seconds. So after 2 seconds, its velocity, acceleration will be 0. Now you have to find the velocity. So then put t is equal to 2 seconds here. You will get the velocity. So I am doing the remaining part here only. So this is equal to, now the remaining part is, since v is equal to 3t square minus 12t plus 3, now you have to find velocity at the end of 2 seconds. Because after 2 seconds, its acceleration will be 0. So this is v at the end of 2 seconds is 3 into, put t is equal to 2 seconds minus 12 into 2 plus 3. So it's how much? 3 into 4 minus 24 plus 3. So this is 12 plus 3 minus 24. So 15 minus 24. So it's how much? Velocity comes to be minus 9 meter per second square. Minus 9 meter per second square, provided that this should be in meter. This should be in meter. And t is measured in second. Then we'll 9 meter per second. You are finding velocity minus 9 meter per second. minus 9 meter per second. Okay, taken the snapshot, taken. Yeah, should I move for the next one? Someone has taken the snapshot? Okay, taken. Now, the next question is the acceleration of the particle in meter per second square is given by a relation a is equal to 3t square plus 2t plus 2, where time t is in second. If the particle starts with a velocity 2 meter per second at time t is equal to 0, find the velocity at the end of 3 seconds. Yeah, finished? Taken? Taken? Taken. Okay. Now question number 4. Question number 4. Number 4. Problem 4. The problem is acceleration varies with time. The relation is given to you. 3t square plus 2t plus 2. 3t square plus 2t plus 2. So acceleration varies with time where t is in second. If the particle starts with a velocity 2 meter per second at time t0. So at t is equal to 0, that is initial velocity is given to you 2 meter per second. So at t is equal to 0, initial velocity is given to you, that is 2 meter per second. Find the velocity at the end of 3 seconds. The question is, find the velocity at the end of 3 seconds. Velocity at the end of 3 seconds. This is the question. Now A, A is dv by dt. So since acceleration is dv by dt, and this dv by dt is given to you. This is 3t square plus 2t plus 2. Now dv is 3t square dt plus 2t dt plus this 2 into dt. Okay. Now integrate. Integrating both sides. Both sides. Definite integral. With limit 0 to 3 seconds. 0 to 3 seconds. 0 to 3 seconds. Now at t is equal to 0, initial velocity is given to you, which is 2 meter per second. And what will be its velocity at the end of 3 seconds, that we don't know. Okay, let it be v. Let it be v. Velocity at the end of 3 seconds. Now just solve it using the concept of calculus. So integration dv is nothing but v. Now limit is lower limit to upper limit v. This is 3 t square dt. Integration is t raised to 2 plus 1 by 2 plus 1. That is t cube by 3. Limit 0 to 3 plus 2 t dt. So t square by 2. That is t 1 plus 1 by 1 plus 1. X n plus 1 by n plus 1. Limit 0 to 3 plus 2 integration dt is t only. Limit 0 to 3. Okay. No integration constant because it is a definite integral. In definite integral, there is no role of constant. Okay. So then 3 divided by this 3. And then upper part is t raised to 3. So t raised to 3, we are putting the limit simultaneously. So if you put t is equal to 3, then 3 cube. Yeah, you are right. T, if you put t is equal to 3, this is 3 raised to 3 minus t is 0. Okay, so 0 raised to 3 is 0 only. Plus 2, and then this is 1 plus 1, 2. And in bracket it is t raised to 2. Now put t is equal to 3. So then 3 square minus, if you put t 0, 0 square. okay, plus 2, and finally t is equal to 3 minus t is equal to 0. Now we have substituted the limit. Now this v is v only minus v is 2 only. This is the way to put the lower and upper limit. So then v minus 2, okay, let me see. So this is 3 raised to 3 is how much? 27, no? It's how much? 3 raised to 3, 27. This is how much? 9, and this is how much? 6. So then v is equal to 2 plus 27 plus 9 plus 6. So 27 plus 9, 36 plus 6. 36 plus 6, 42. So the answer is 44 meter per second. 44 meter per second. Velocity at the end of 3 seconds. So these are the numericals in which you will see the vital application of calculus mathematics. Calculus mathematics. Though the numericals are from physics and you need calculus to solve to get the answer. Okay. Now question number 5. Take the snapshot. I will solve the next question. Taken? Page I forgot. Page number I forgot. Okay, you will understand. Question number 4. Then I will write question number 5. So now we are doing question number 5. So question number 5 is number 5. The question is, a car accelerates from rest at a constant rate A for some time, after which it retards at a constant rate B to come to rest. So this is the scenario. A car accelerates at a constant rate A, acceleration is given to you, and then it retards at a constant rate B. But the time interval is not known to you. Suppose this time is t1, this time is t2. If the total time elapsed is capital T, this is t, and this is speed or whatever velocity you have taken, this side. Say car accelerates from rest at a constant rate A for some time, say t1, and then it retards with a constant rate B for sometimes to come to rest. If the total time lapse is 3 seconds, now evaluate the maximum velocity reached and total distance traveled in terms of A, B and T. So actually you have to consider a speed here. Okay. So calculate maximum speed, Vmax. So this is your Vmax. This you have to calculate. Maximum speed. The first bit is you have to find Vmax. Second bit is the total distance covered. Total distance covered. Distance covered. Remember one thing, the total time elapsed is capital T only. It means T1 plus T2 is given to you. This is T only. This time is T. 0 to T, total time. So T1 plus T2 is T. Then how will you find the Vmax? Your answer will be in terms of A, B and this capital T. Only 3 quantities are known to you. Capital A, which is acceleration, capital B, which is retardation, and total time T elapsed, means total time taken. This capital T is given to you. Okay, so let me solve this problem. What is the acceleration? That acceleration part is, acceleration is given by Vmax by T1. Means perpendicular, I mean slope, tan theta. Tan theta is perpendicular by base. So perpendicular is Vmax divided by base is T1. So this way you can get T1 from this relation T1 is equal to Vmax by A. If you find B, then again it is Vmax by T2, writing only magnitude. Okay, B is equal to Vmax by T2. From here you can find T2. So T2 is Vmax by B. Okay, so now the condition is T1 plus T2 is capital T. So T1 plus T2, just add these two. Vmax by A plus Vmax by B is equal to T. Now take Vmax common. So then it is 1 by A plus 1 by B is equal to T. Now take the LCM, this is A plus B by AB. So then Vmax is equal, Vmax is A plus B by AB and right side it is T. So what is the value of Vmax? So then AB into T divided by A plus B. Divided by A plus B. So acceleration, retardation divided by acceleration plus retardation into this T. Into this T. This T. Okay? So this way you are getting the maximum velocity. Now how will you find the total distance covered? So to find total distance covered, total distance covered. This is second bit of the question. This is first bit. So we are doing first bit. Okay, second bit, total distance covered is nothing but area of speed time graph, area bounded under speed time graph. So area of the triangle, if I can name it O, A, something B. So then this is area of triangle O, A, B. Okay, area of triangle is half into base. So this base is nothing but T, capital T. And this height is nothing but Vmax into Vmax. So let me put the value. This is T by 2 and Vmax you have calculated. This is AB by A plus B into T. So it's nothing but AB by A plus B into T square by 2. This gives you the total distance covered. So total distance covered is AB by A plus B T square by 2. Yeah? Take the snapshot. Taken. Now just remember this formula. Vmax is AB by A plus B into T and total distance is AB by A plus B T square by 2. Now I will ask a very simple question. I will give you the value of A, B and T. Then you have to find Vmax and the total distance covered. Okay, question number 6. I am dealing with the question number 6. So the question is, now I am not rubbing the formula part. It will be helpful for you. Question number 6 is, now the sixth question is, a car accelerates from rest at a constant rate 36 km per hour square. So suppose A is given to you, 36 km per hour square. And then for some time, after which it retards at a constant rate 48 km per hour square. So B is given to you, 48 km per hour square. Okay. 48 km per hour square to come to rest. So the question is, if the total time elapsed is 1 hour, then you have to find Vmax. You have to find total distance covered. Yeah? Can you do it? You can do it by using this formula. Very easy. Easy. Vmax. So formula is product by sum. So take the product, 36 into 48 divided by 36 plus 48 into t. T is how much? 1 hour. So this is 36 into 48 and it's how much? 84 into 1. Can I cancel it? See? So what will be the final answer? You just solve it. You will get 20.57. After solving, you will get 20.57 kilometer per hour. This way you are getting Vmax. And at the moment you want to find S, total distance cover. Again same thing. Once you get this one, this portion, I am writing directly 36 into 48 by 84 into t square. That is 1 square by 2. So then it will be half of this. So because this portion is already calculated, 20.57 divided by 2. It's 10.29 kilometer. 10.29 kilometer. You can solve it. Not a difficult task. You have to multiply and divide. Yeah? So just putting it in formula, you will get the result. Or you can do it by using direct method also. If you forget the formula, you can do it directly. Okay. Now I am solving the interesting question. Today's interesting question is the acceleration. Yeah, take the snapshot. I will rub the board. Yeah? Taken. So now question number 7. Now you will gain the concept slowly because the more the numerical you will solve, the concept will be more and more clear. Because this particular chapter is numerical based chapter. The more you solve the numerical, the more your concept will be crystal clear or transparent. Okay. So this question 7 is the acceleration experienced by a moving boat after its engine is cut off, shut down. Engine is cut off. Is given by dv by dt is equal to minus k vq. Minus k vq. So obviously it is following a negative sign, means retardation will be there. So once the engine is cut off, now the boat starts decelerating. The speed of the boat starts decreasing. And that's why it follows the negative sign. So deceleration is there. Where k is a constant, this k is a constant. Where k is a constant. If v naught with the velocity, magnitude of the velocity at cutoff, v naught be the magnitude of velocity, at cutoff, then you have to find the magnitude of velocity at time t after the cutoff. Find the magnitude of velocity after time t. After time t, find the magnitude of velocity at time t after the cutoff. At time t, after the cutoff. After the cutoff. This is the scenario. Okay. One boat is plying or sailing in the river, and after some time the engine is cut off. So what will happen? The boat starts retarding. Means the speed of the boat starts decreasing. Now the question is, find the magnitude of velocity at time t after the cutoff. The instant you have cut off the engine, now after a time interval t, what will be its velocity? You have to find the magnitude of that velocity. This is the question. Okay, so should I move? This dv by vq, it's how much? Minus k dt. So this I can write v raised to minus 3 dv, it's minus k dt. Okay, integrate it. Now integrating both sides with the limit. Now v naught is the magnitude of velocity at cutoff. So if you consider this time as 0, then velocity was v naught. Okay, your time starts from 0 at the time of cutoff. So the moment engine is cut off, your time starts. So then t is equal to 0. At that time, what was the velocity of the boat? It was v naught. Now at time t, you are going to find, this is t. Okay, no problem. I can write here. Now at time t, its velocity may be v or v dash, whatever you can think. So let its velocity be v. Then just integrate it, you will get the result. So x raised to n dx. So what is the way to integrate? V raised to minus 3 plus 1 by minus 3 plus 1. Limit is v naught to v. And this side minus k, integration dt is t only, limit 0 to t. So this is v raised to minus 2 divided by minus 2. And the limit is v naught, v, and this side is minus k, and just put the limit, t minus 0. That is minus kt. You can say, but I have to solve now for all the children. Okay, so this is minus, yeah, minus 1 by 2, yeah, and 2kt, v naught square plus 1. Yeah, you are right. So v naught to v, v naught to v is equal to, the right side is minus kt only. Okay. Now the next step I am writing here, next from here only. So this is minus half. Now let me put the limit. 1 by v, v is v only. Okay, v square minus 1 by v naught square. And this side it is minus kt. Okay. So this is equal to minus half, and this is 1 by v square. Okay. So you have to find v square. Okay. So bring this term, this is minus into minus plus, and if you bring this side, it will be minus again. So then this is equal to minus kt, okay, plus minus into minus plus, and then if you bring it right side, it will be minus. So then minus, it's how much? 1 by 2 v naught square. 1 by 2 v naught square. Okay. The next term is, I am writing from here. So this is minus 1 by 2 v square is equal to, take minus common, and then LCM also. Okay, take the LCM. This is 2 k v naught square t. Then minus, you have taken common, plus 1 divided by v naught, 2 v naught square. 2 v naught square. After taking the LCM, just cancel this 2 with this 2, minus with this minus, and then take the reciprocal. You will get v square. So this implies v square is equal to V naught square divided by 1 plus 2 k V naught square t. And if you take V only, then you have to take the square root. So I am writing the final answer. V equals to V naught taking the square root of the denominator is 1 plus 2 k V naught square into t. Yeah? Do you feel any problem to understand this question? So everything is crystal transparent. Only thing is you have to write in copy in sequence, because here I have no space. That's why I'm writing sometimes here, sometimes here, sometimes here. So then if you are writing in sequence in your copy, and then if you study this one, it will be more clear. Okay? So you have written, taken the snapshot? Yeah? Taken the snapshot? Taken? Taken? Okay, okay. So time is over? Over? Or we have few 5 minutes more is there with us, no? No, we cannot take more 5 minutes more, no? So 2 minutes? Can I take 2 minutes? Yeah, this is very interesting question. That's why I'm taking 2 minutes. So the question is, question number 8. This question is, acceleration A is given by minus omega square r sine omega t. What will be the acceleration? What will be the expression for displacement? What will be the expression for displacement? What will be the expression for displacement? So you have to find the displacement expression for displacement. If acceleration is given by this relation, so how can you find it? Omega is angular velocity. I mean angular velocity, you know, d theta by dt. Okay. So this acceleration is dv by dt. So dv by dt is minus omega square r sine omega t. So yeah, A is equal to minus omega square r sine omega t. Minus omega square r sine omega t. Sine cosine, sine omega t. Then dv is equal to minus omega square r sine omega t, this dt. This is dt. Okay. So then, how will you find the displacement x? The question is, how will you find the displacement? So this way you can find dv. If you integrate it, you will get v. And then v is equal to dx by dt. So dx by dt, then you can get that relation. So can you find it? Because time is not allowing, so I can do the same question in the next class. Okay, so let me finish